Okay, so my talk is about event-driven and multi-agentic architecture, and primarily will just be more lecture. I won't be talking for too long. I mean, as such, it's already late, so it's just going to be a shorter talk. And then also, I won't have any example, but I'll be sharing with you my live stream because sometimes I'm trying to get back to doing live streaming, and then I can do more coding from there. But today is a bit more of conceptual. But I should first ask you, how many of you are already working with more agentic type of workflow? I'm kind of wondering. Oh, okay. Yeah, feel great. And then also, how about event driven, like using streaming, for example, Kafka and things like that? Have you? Yeah, some of you do. Okay, but I just want to get an idea, just so I know how much to get into, right? If I need to get into some more details of something. So thank you. And so this is the agenda. Who's Mary first, and then just give some introduction to Gen AI and agentic architecture, why, they are can I do believe there's a lot of synergy in terms of, applying event streaming kind of techniques to agentic type of workflow situation. So we'll talk a bit too about event-driven world AI. And also an important aspect is distributed computing. And I believe that's what is going to bring the current state of the LLM, all of these things to the next level. It's basically doing agentic and making use of true like distributed computing techniques in terms of managing data. Because when we want to do something more serious about it, to deal with an order entry goes, those kind of things, right? You need to make sure that you want to maintain data consistency and is crossing different boundaries, all of these things. So we'll just get a bit too into data engineering. And then just talk about applying event approach to RAG and doing agents and workflows. So that's my plan for today. Who's Mary? So picture worth is worth 1,000 words. That's me. I'm also the Chicago Java Users Group president. So I'm based in Chicago. I'm also Java champion, and I was a software engineer for maybe 20 some years, and of which like year 2000 was when I started working with Java. And then also I moved to Chicago, and I was born in Hong Kong. And then I came to the US for college in Massachusetts, and then lived in the Bay Area for a few years, and then now in Chicago. I've been there for over 20 years now. So I'm running Chicago Java Users Group, and then I have more interest in distributed computing. I do believe whatever we're doing is going to touch on some form of distributed computing, that type of stuff. So and also, too, currently I am in between jobs when I'm on sabbatical, I call myself. But I'm helping this group called AI Collective, and it's a grassroots organization, think tank, and we run a lot of events as well, and also helping like founders and investors as well. So folks can come and do pitches and things like that. Also, we have chapters too, very active everywhere. So I'm helping with the global expansion. I'm actually the VP of global expansion for North America and Latin America, just so you know. So if you want to get involved too with AI Collective, if folks doing AI want to do presentation, let me know. I can also connect you to the right chapter as well. So, okay, so I'll start. I want to demystifying a bit of generative AI and agentic architecture. So just first of all, like when we're working with AI and machine learning, is essentially we're working with data. The data is really at the center of things here. And basically, Gen AI, as we can see, uh, essentially is at the core of all of deep learning, but it works also very closely with natural language processing, NLP, and works with LLM, deep learning on that level. So data is very important. I just want to highlight that. And of course, there are generative models such as these that are very popular that we're working with. And also to the platforms too, we can have platforms and apps. And so basically there are cloud platforms that are AI optimized for doing AI, such as all the major players like cloud hyperscalers, Amazon, Microsoft, and Google, all of these things. And then there are plenty of apps that we're all trying to build up. So that's what it is. But the thing is, though, I think it's what is kind of fascinating right now fascinating a lot of people is the fact that it is still kind of pretty much a one-shot deal. We know that we're using LLM to ask some single question to do something. That's what it is very more or better at. But we know that LLM itself is not deterministic. It's non-deterministic. There's no memory, and all the algorithms are just, fuzzy logic, essentially. So if you ask the same questions many times, you're going to get back different answers, not exactly the same. That's just the nature of LLM. And also, it's very expensive. It's cost to nobody think of it, but the fact that it still costs a lot of money. Data center processing, maybe the same kind of query you want to do the old-fashioned way, compare it with using LLM to do searches. But actually, LLM isn't really doing searches, it's essentially doing pattern matching, strictly speaking, right? So all of these things, I mean, not to say LLM is bad, it's just that it has its limitations. And also, too, you can't add any attributions to its answers, too. So all of these things, and also it being so much of being one shot kind of usages. You ask it questions and it answer well. But what if you want to like say, I want to place an order and just give it some, parameters. I'm going to, once I want to book tickets, to fly from here to there, something like that. And then you give it a bunch of stuff that the LLM can't just figure it out by itself. And that's when you need something like agents to help it. The agents is sort of act as the glue and everything to help it, because especially in enterprise kind of situation, we're talking about scalability is important. Complex task that requires workflow. And again, touching on a lot of data that needs to flow in different network boundaries. How do you keep data consistent? How do you keep the state information, all of those things? And that's when I feel we need to get into more event-driven type of architecture that addresses some of the needs in there too. So that's what it is. So let's get a bit into agentic architecture. So agents as such is not new, as we all know. But I think the marketing has a way of this world has a way of making it sound like it's new every time. But essentially, too, agents, if you think of Linux systems, all of these Unix systems, they are already doing agents. They are essentially specialized way of, operating things with the machine. And it's basically also agents to themselves. They handle certain functions well, does its job real well. And also within AI systems, we're talking about it being able to do things autonomously too. So there's sometimes, in some cases, there's no need for you to explicitly tell it what to do, because that's part of the job of agents, kind of going to work with LLM and figure out the steps and planning all of these things too. So that's more agentic architecture applicable for AI systems. And also too, it should also integrate with different tools kind of autonomously, and scalability side of things, it needs to be seamless. Also, too, it should also take care of resiliency and recoverability too, that aspects. And then some more key concepts too, in terms of architecture is basically, we're talking about you can have vertical architecture, in that case in which you can have one agent like leading, be the leader to decide on things, maybe like in doing orchestration, things like that. Or you can have multiple agents, because as such, each agent is specializes in certain tasks. And then in complex situation, you can have, multiple agents. We need to have multiple agents. Let's say going back to the airline ticket operations, and you can have agents that are actually figuring out your schedule, some agent that is dealing with pricing schedule and availability of flights of different carriers, things like that. So in that case too, you can have horizontal architecture in which each agent is doing its own job, but they can all come together and figure out, having an agent orchestrator to be orchestrating the whole set of workflows. So now we're talking about agentic architecture for real, kind of real life, kind of more complex kind of enterprise kind of application that can take care of also autonomous decision making and reasoning and planning as well. And also to agent itself to, by definition, it needs to be adaptable to. That's also another aspect of what it means to have an agent too. So it needs to also be able to continuously learn. And basically, from the data, it should also be adapting as it is learning from the data itself. So, and ultimately, too, we actually want agentic architecture to be able to not even require any human to be in the loop. But as such as today, as we see, doing something more complex too, we still are requiring a lot of human in the loop. So event-driven world and AI. So at the heart of AI is really data. Data, without data, there wouldn't be any AI or machine learning, as we all know. And then, of course, data too, especially when I've been working with a lot of data streaming stuff, then I look at data in a different angle. It's basically dealing with the flow of data in many directions as well. So on the architecture level, we're talking about applying like event-driven type of architecture. And then also too, we have to be aware of data being in different states. It can be at rest, meaning data is in some form of storage, database or file systems as examples. And then also data can be in transit. They can be traveling, being sent from a node A to node B, for example. So that we're talking about network communication and nodes. And also data can also be in use too. We're talking about, data that we need to extract and then have to manipulate it or operate on it or transform it. Let's say an order, we're working on an order, the order status change, all of these things are basically they're being transformed as it is being worked on. So techniques too to work with this kind of thing would be like event streaming. Like example over here is kind of they're similar to event streaming, event messaging. So it can be like Apache Kafka. This is really popular in the Java world, and we're talking about streaming is when data is being continuously being sent out, right? It's also being triggered by events too. Some events happen and you need to take care of it. Also, for example, Apache Pulsar is another also quite well, I guess it's not as adopted as much, but still, it is more built for more cloud native kind of usages too, I'd say. It came after Kafka, but that's another example of an event streaming type of platform. And then Red Panda or Solus, they have event store, for example, things like that. And then another techniques that are also being used, especially in data engineering, ideally too, is to use event sourcing. So event sourcing is, if I kind of give an example, is basically an example of, again, going back to an order entry. So traditional way is that we store orders in the database. Each order is being stored kind of once, but you have a status field that kind of indicates the state changes of this order. But ideally, too, we want to do is to be able to track the change of the state changes of this order over time. So in that case, and the techniques being used is called event sourcing. So anytime you basically want to record every time that state is changed, then you want to record something about this order. So for example, the status column is changed. You log its time as well. So that's actually very useful, especially in cases when you need to do replay and say, you're doing trade, doing trade operation, trading, right? Trading apps and stuff like that. You can actually go back in time and say that, well, I don't know what is happening. This order isn't right. Let's go back in time and do tracing like that. So that would be more event sourcing kind of way of doing things. And also CQRS, I wanted to mention here, is basically stands for Command Query Responsibility Segregation, is also like a pattern that helps with dealing with separating out the read and the write concerns. So then you can achieve kind of efficiency in writing the log records as well as reading from the logs too. So that's kind of some of the techniques that are being used in more complex data engineering. Okay. And now let me then look into generative AI streaming usages. And basically, if you think of it, we live in a very complicated world that's actually largely event-driven. Nobody would be doing things and stand there and wait. We're needing something. Let's say going to the store and buying something. You get a ticket at a deli store, for example, you waiting in line, you get a ticket and you go do something else, and then your number is being called. So that kind of purpose of why streaming is very much event streaming is very much related to real life. So in Gen AI type of application, we're talking about prompts, and prompts can come at any time, and it's from the command line or from the browser, from mobile apps, all of these things, and then the intermediary steps is like, say, doing a RAG operations. You are sending some prompts to an LLM, and then you using retrieval augmented generation. The sources can come from like a database or file system or sockets and message queue, for example, all of these things. And then eventually too, you want to enhance the prompts with this process and then send the request over to the LLM. That's all streaming. You can kind of think of it like that. And of course, responses coming back from the LLM and then pass through the generative model, then that gets streamed back to the sender as well. So these are kind of example of how Gen AI is also making use of a lot of this streaming type of usage scenario. So the benefits of this event-driven approach is we're able to then handle this dynamic nature of data and its flow patterns, and also allow it to the communication to be more asynchronous too, via event streams. And in this case, because all these components are independently not coupled together, right, loosely coupled, so it helps with scalability and flexibility, especially if we're talking about using event messaging to do this kind of things. You have brokers that are handling the publish side of the data as well as subscriber side of consuming it as well. Also, too, in some cases, maybe like with Gen AI type of usages with agents, you can have certain agents just only work with one LLM and another agent work with another LLM, maybe because you have a complex system that you're dealing with video data, so it works, one agent working with Sora, for example, video kind of data for LLM, and then you have another agent work with some other model. So in this case too, maybe you employ more of an event-driven approach. It makes it easier to kind of independently manage them as well. But then also remember too, like when you do event-driven stuff, it tends to be more difficult to debug, harder to track all the flow of calls. So just it's possible, just make sure that we put in place all of the proper observability type of tasks to monitor it as data changes too. Okay, so now I'll get a bit into distributed computing and agentic AI. So just wanted to talk about this CAP theorem too. These are like the three fundamental aspects of data in a distributed system kind of thing. So the CAP stands for consistency, availability, and partitions tolerance. So this theorem is basically states that only two out of the three aspects are guaranteed. So network, let me kind of go back into the partitions part first, because as we all know, right, when we deal with working with distributed systems, we're relying on the network. But in reality, network is never reliable. It can be, disconnected. So you create some kind of connectivity issue. So that's why it's partitions tolerance. So basically, if there's partitions tolerance, meaning there's no connectivity, then what do you choose, right? Do you actually want to, if requests coming in, do you want to make sure, well, there's no way you can give a consistent answer when there's no network available. But then in that case, if you want available data to be available, that the clients will get back a response, then basically it's not from the most recent write. So then the data itself may not be the latest, all of these things. But then we do believe it in some cases too, if you are kind of going with availability, then you guarantee that there's always a response, but also eventually. That's what eventual consistency means, meaning that eventually if the network comes back, then you arrive at data that's more consistent. That's the latest. And so that's what it means. So this is the CAP theorem. And that's something I believe eventually, if we're kind of especially working with agents and helping with more complex kind of workflow and data in different network boundaries, this kind of aspect needs to be addressed as well, is what I feel. Okay, so so as such too, with this CAP theorem, I just wanted to kind of point out too, not all databases are created equal. So it's and also we're saying that not all applications have to follow one versus the other two. You know, do you pick availability or do you pick consistency first? So it depends on your application. So actually, in a generative AI type of scenario, let's say you have prompts and you want actually answers to come back quicker, then you probably want to choose something that supports availability, right? And in a CAP theorem kind of scenario, in a distributed kind of scenario. So this is just a diagram that I got, that I found out. It's quite popular. It just lists out, it depends on your usage scenario. You probably want to pick the right database for what your needs are, your specific needs are in this case. So say, for example, yeah, the one below, there's a DynamoDB or Cassandra. All of these, they are more like about availability. So they tend to be like they pay more attention to more responsive too. So if there's network partition, it will always have an answer, but the answer may not be the most accurate. That's what it means. So if that's more important to you about responses, then you might want to choose those databases that are at the bottom in there. But then there are also, for example, on the right side, there's more dealing with consistency and to a certain extent also availability would be like Oracle or MySQL, all of these other databases. And then also too, if you really want data to be more accurate than consistency on the left side, then there's Google Bigtable, HBase, MongoDB, all these, they are more like they more consistent. They follow that better too in cases of like partition tolerance. So you may not get your answers back as quickly, but you eventually get it and it will be consistent. And that's what it means. So okay, so now too, and just kind of a little bit more extra information. Now, CAP theorem isn't the only thing, but there's also this theory that extends the CAP theorem, and that's Parcel. So it stands for even well, under cases in which there's partitions concerned, then consistency and availability would need to make some compromise between the two. But then else is if there's no concern about network partitions problem. That means network is always up. You still need to make a decision between latency, meaning that, how fast do you get back a response, and also the consistency of the answers too of your data. Okay, so now this one is basically again reframes. I already mentioned too how Parcel can kind of reframes Gen AI because for Gen AI the else part is basically dominates too. You basically users will expect streaming tokens is less than 1 to 2 seconds and pushes you to a lower latency read too, if often without eventual or session consistency too. So that's what in this particular case is what it is. Okay, and then there's also CQRS and agentic AI, so the command query responsibility segregation. So CQRS again is a software architecture pattern. It separates out the data model being used for writing and reading queries. And as such too, it's important because it impacts like data storage requirements too. But the thing is, though, it also suits quite well with dynamic needs of agentic AI system too. So we're talking about the serious types of agentic end-to-end enterprise level type of systems too, because we need scalability, concurrency, and performance and resilience too in that case. Okay, so now I'll just quickly kind of step through. There's applying event approach to retrieval augmented generation RAG, right? RAG is kind of being now used all the time for those of you, especially working with LLMs, with AI types of application. But essentially, this is a hybrid framework that integrates like two components. The two components are retrieval model and generative model. So they are not like very complicated as we know. And as such, because LLM itself, it gets trained, on older data. So there's a need to, if we need more up-to-date data, we need to use another techniques, and that's when RAG can come into play. So the retrieval, this is just a diagram describing it, although I'm not using something too fine-grained because here I'm just assuming the data set isn't too big. So you can actually just have RAG and get all your data in one shot rather than having to chunk it, for example. Because in some cases, right, when you need to read in huge amounts of data, for example, like you work for a hospital or something, it's got large amounts of data that can't fit in the context window, then you have to break it up and divided up the data into different chunks, and then that's another technique because how you divide it up, how much overlapping will affect the results that you'll be getting. But in this particular case, it's a simple case talking about regs. So user submits a prompt to the reg application in step one. So the reg will then essentially do a semantic search of some kind, maybe to a vector database. It's basically it reads from that database some additional kind of context in order to build it up and add to your existing prompt, enhance it. And so in that case, then you go to step three is when after you enhance this prompt and then you send all of these relevant context over to the LLM and then receive the response. And then response will come back, from the reg, sends back to the user as well. So just want to kind of quickly kind of go over this. And as you can see, well, here too, role of the retrieval model is basically it acts as a specialized kind of librarian pulling in relevant information from a database or a corpus of documents too. And then with this, it will then eventually feed all the data from the LLM back to the generative model. The generative model will then act as a writer and in crafting up the results. That's why now when we're asking ChatGPT to write something, a prompt, and then it's essentially the generative model beautifies it, essentially make it more contextually rich. Okay, so then this is the generative model I already talked about. Okay, so now I'll also talk a bit then about the applying event approach to agents and workflows. So back to a bit agents again. Agents is essentially one who is authorized to act for or in the place of another. And so it's kind of like, insurance agent too. It's like whatever agent, right? It does things on your behalf like that. And again, just want to emphasize agents is supposed to be adaptable and doing things very well, one single task really well. That's kind of the definition. Generative AI agents are essentially, they orchestrate complex workflows and coordinate activities of multiple agents as well. And doing all of these things, it basically does work on your behalf. And then in reality too, we very rarely, I think, especially if we work with more complex system, we probably will involve multiple agents. So that's when we're kind of bringing in this multi-agentic systems. And basically, these are multiple autonomous agents working together. So each agent will specialize in different tasks. And also, too, the agents themselves, also, you have some level of agents that can divide up some complex tasks into some manageable subtasks, too. And then leverage the strengths of different AI models as well. So that's kind of multi-agentic system that should actually kind of work very well too with kind of event-driven approach as well as we can see. And also, as such, right, I just want to kind of bring it up to their protocols that comes out, model context protocol. Now we're talking about agents, that agents also needs to be dealing with the resources, talking to LLMs, all of these things. So they can do it any way they want, but then that's when the need for some standards that needs to come out. So model context protocol, MCP from Anthropic, came out is an open protocol that standardizes how applications should provide context to the LLM, and you could be interacting with different database, all of these things. So this just basically adding this kind of protocol to standardize how you interface with the more like the infrastructure layer too. And then what other thing? So the next thing is basically another protocol that also came out recently, not too recent anymore, in June, Google. So they came out A2A, agent to agent, and that one they're actually more complementary to MCP because they have different levels of concern too. So over here, just a quick diagram to kind of explain. As you can see, A2A is more for agent to agent exchange, message exchange too. And then as you can see in this diagram, the MCP part is basically a bit lower level that deals with like agent development kit and talking to all of the, maybe lower level resources and databases, things of that nature. So they don't really interfere with each other. They just complement each other. So these are the different protocols. So here too, just wanting to get a bit more into this combining like event-driven architecture with multi-agent for generative AI type. And these are just, again, some examples too. We can be using like different events to coordinate different agent activities. And then and then there's also event streams that can enable asynchronous agent-to-agent communication as well. And then event-driven workflow that can help to orchestrate this multi-step generation as well. So you could have multiple components in an event-driven system. You can have event bus that manage all of the event streams and API gateways to handle like external events as well. And then agents themselves are autonomous components with specific capabilities. And also too, they each work with different AI models as well underneath the hood, so to speak. And then there are different event types and agent types that we can also be like adding to your application to handle the different types of agents, like a coordinator or generator or evaluator or refiner, something like that. And then event types could be user requests and subtask agent, subtask like assign, for example. So every time if there's those kind of events that happen, that the event would get admitted. So once it's admitted, it should be autonomous, right? Once you kind of define your system that certain events happen, then it automatically trigger some action to it too. So it kind of, I think it drives very well to essentially with agentic type of operations and flow too. So that's just what it is. And here too, it's just a diagram explaining to the AutoGen, which is a Microsoft open source agent SDK that is actually is good for building like chat type of conversational style of application too. So this too, I'm also have already shared like a link if you're interested in it. So I'll be sharing this slide deck afterwards. And then just a word too about agents too. There are also agentic design patterns that comes with it too. So that now kind of like looking a bit more into, implementing agents and following some design pattern, there's essentially like four. There's reflection, tool use, planning, and multi-agent collaboration. And just a note too, these are what I've kind of read about and wanting to summarize in here is from Andrew Ng, who's like the famous uh, AI person, right? Well, AI kind of doctor person, and he's the one that started the deep learning.ai and also the AI funds too. So this is something that I extracted from his newsletter. Okay. Okay, so just a quick note too about reflection is basically we're talking about having agents being able to do some tasks. So in kind of a typical kind of implementation scenario, you can have like say a coder agent. In this case, you can ask the coder agent to do some task you explain, and then the coder agent will work with the LLM and generate the code. And then on the other hand, we also would have critic agent or what is also called eval agent. So eval agent is there to kind of is essentially looking behind the back of coder agent, making sure the coder agent is doing the right thing, or actually through the coder agent to the LLM. So I'm going to kind of like here, the critic agent could be like looking at the answers and then realize it isn't right, and then telling the coder agent to improve the answer. So the coder agent will then go back to the LLM and say, please, I'm finding some problem. Please enhance it like that, and so on and so forth. So that's a reflection kind of pattern that we can essentially, if you're coding agent, you're coding your coder agent, you can have it do this kind of reflection autonomously, automatically as well. So until you get, over time, you should be able to get better answers as you go through many iterations. So that's what it is, an example of reflection. And then another agentic pattern is called tool use. Is basically you want to essentially you want to code it up so then you're basically assuming that sometimes the LLM may not have the proper answers. So in that case, you want to configure it and tell the agent and said that if you can't get a proper answer from the LLM, here it is. You can use, for example, a Wikipedia page or using some other web page and tell the agent to kind of use it as a fallback. And so this is kind of another pattern of a tool usage for an agent to do too. So Okay, this one is just an example from Crew AI, but I won't step over it for now. But I just want to get to this is about planning. So planning is essentially now we're going to rely on the LLM and generate the steps that are needed to perform a task. So in other words, we're not going to tell the LLM what to do. Is basically through the agent, I'm going to say, I need something to be done, and then have the agent talk to the LLM, and then have LLM figure out all of the steps that needs to be done on its own. But I think just based on the research result, I think this is not always very accurate too. Maybe it's better now because I read about this like 6 months ago, and it says that in their lab, Andrew Ng said that in the lab they were doing a couple tests, and it's not always very accurate at that time. But anyway, so this is an example. You could be doing something such as giving the LLM an image of a boy riding a scooter. And then from there, you can just say, I want another picture of a girl in the same posture, but will be reading a book. So then in that case, it needs all of the steps that needs to happen. It needs to first maybe like figure out, what is the look of the boy. And then from there, then you say, look for the girl. And then from the girl, then you say, I need to read a book, right? That type of stuff, all the steps essentially. So now you're basically having an agent to kind of work with the LLM and plan out all of the steps that needs to happen. So that's kind of like another agentic like design pattern that ought to be the case too. Okay, and then here too is just another example is essentially the ultimate. It's basically you want a true multi-agentic collaboration. But in this particular case, it's also documented in here in deeplearning.ai is an example of an IT project. And then you can have different roles in there, a designer, a coder, tester, a documenter, whatever it is. And then you basically are relying on the agents to actually be autonomously doing its task accordingly too. But I think again, this actually particular example is citing is actually there's like a prototype app too that's in GitHub that is inside this article. So if you want to read about that, and I find it to be quite interesting because this would really mean is a true agentic, multi-agentic collaboration. You have really different aspects of tasks that needs to be coordinated accordingly and perform tasks well too. So okay, so that's that. And just an example, example of a few multi-agentic libraries. If you're working with it, there's AutoGen from Microsoft or Crew AI. In fact, I was just there today at the summit. They are actually a popular agent SDK, but they are role-based too, just so you know. And then LangGraph came from LangChain. That's a graph-based type of agent enabling you to write agents too. And AWS also has SDK called Strands that came out quite recently. And Google has Agent SDK. And on Java side, there's also Quarkus with LangChain 4J that's based on CDI as well. So something to share with you. And then some code examples are also in here if you're interested. And for Java and AI workflow, there is somebody working on a workflow on it too that I'm sharing in here. Otherwise, Crew AI is Python, just so you know. So okay, so challenges, just wanting to kind of sum up a little bit. So just be aware of the following issues, especially if we're talking about using event-driven approach or whatever approach, but we know that these are complex, can be complex too when you deal with more distributed systems. And you need to make sure things are coordinated properly and ensure data consistency across the distributed agents. You need to be able to handle failure and partial results, all of these things, and you need to also optimize them for latency and resource usage, sustainability issues. We know that again, LLMs, all of these are kind of large language models are energy hog, not very eco-friendly too. Still not the case, and still you're still getting hallucinations with LLMs, and also another very important aspect I believe for AI agents is also security, safety, and responsibility. I think that's also never been really truly been discussed anywhere. There have been a lot of talks, but I think really when we talk about it, I also have often thought that, yeah, we can put in guardrails, but how do you know? Let's say if my agent is doing things and it generates some kind of web page, how do you know the web page is not fake, right? How do you know the page is not, like some scammer, things like that? Well, how do we check that, right? Can the agents check that? Can the agent actually present the answers to whoever is asking? Those kind of things, I think we need to really be thinking about that too. And of course, also with ChatGPT, Gen AI types of scenario, we're talking about prompts. You can have prompt injection too, just like SQL injection. All of these things we need to be aware of. So, okay, so then with that, my talk is pretty much comes to the end, and this is the slide deck. If you're interested in the QR code, I can also share it with Sasha too, and with the group too. So you don't need to worry about it if you don't catch it now. Yeah. Okay. All right. And also just a couple papers too that I'm sharing in here for the archive for the AutoGen one especially. And then also I wrote an article on the Java Advent Calendar on event streaming too. And that one I gave some more examples on that, and just so you know. So and let's see. And that's it. And oh, I have a stream too if you want to follow me on Twitch or YouTube. I actually multi-stream to both. I just need to find time to restart my stream. So just haven't got time. So with that, I want to thank you again. Thank you so much, San Francisco, East Bay Java Users Group, to Sasha, to Benjamin, and to Peter. That's right. Thank you so much. Yeah.